Hello students, I am Isha Mendirata. In today's video, I will be discussing various fiber configurations along with fiber optic communication link. So starting with the first topic for today, fiber configurations, wherein we'll be seeing the three major fiber configurations which are commonly used. Now let's see these fiber configurations. They are obtained by combining the modes of propagation as well as the index profile. What do you mean by the modes of propagation? It is the different paths that light takes or light follows to travel down the cable. So there are two types, single mode and multi-mode. Then you have index profile. What is index profile? It is a graph of variation of refractive index along the y-axis, that is vertical axis, and distance of fiber along the horizontal axis. So depending upon these two parameters, we have total three types of fiber configurations. The first one is known as a single mode step index fiber, SMSI. Then you have multi-mode step index, so multi-mode MMSI. Multi-mode is MM, step index is SI, so MMSI fiber, and the third one is known as multi-mode graded index fiber. So we have SMSI, MMSI, MMGI. These are the three configurations which we are going to study in detail today. Starting with the first one, that is single mode step index fiber, which is a combination of single mode. So from the name itself, we can say that light will take only one path to travel along the cable. And coming on to index profile, so light has a step index profile. Now what do you mean by a step index profile? A step index profile is a profile in which throughout the core the refractive index remains the same. Along the entire diameter of the core you have a single value of refractive index. A single mode step index fiber is having a uniform core material and it has an extremely small core diameter. From the name single mode, you can say the diameter is very, very small. And what is the range of such core diameters? It is 7 to 10 micrometers. So single mode step index fiber is a fiber having a uniform core material and an extremely small core diameter, so that there is only one path for light to travel along the cable. So it has a very small core diameter and it has same refractive index throughout the core. This is the meaning of SMSI fiber. And this is how the fiber can be explained. So on the left side, you can see the front view. The cross section shows only two layers, core and cladding, because rest are the protective layers. We are only concerned with core and cladding at this point of time. Then you can see the graph. What is this graph known as? This graph is known as the step index. Step index profile. This graph is the index profile, and in this case, because the core refractive index is uniform, we are getting a step index profile. And then the rightmost side, right hand side, you can see that you have core, very small diameter because it is single mode, and then you have blue colored cladding, and in between them you can see that red colored light is propagating as a single path only. This is the meaning of single mode step index fiber. Let's see some properties of this fiber. So it has a very small diameter of core with uniform refractive index. It has a cladding which also has a uniform refractive index, and that is of a lesser value. Obviously, the cladding should have a less value compared to core, otherwise you won't get TIR because one of the conditions won't be satisfied. Next, you have high information carrying capacity. Why? Number one, attenuation is less because it's a glass fiber, and single mode. So entire information together is carried without any data loss. Light rays entering the cable follow the same path and take the same time to reach the output end because all the light travels as a single line. There is only one, I would say, a disadvantage of this type of a cable, that because the diameter is very, very small, it is difficult to couple light into the cable. What is coupling of light? Incidenting light or sending your data in the form of light into the cable. That is a bit complex process. So these are some of the properties of single mode step index fiber. Now let's have a look at the propagation mechanism of single mode step index fiber. You can see from the diagram that whatever light is coming out from the laser, that is the transmitter part, is moving throughout the cable as a single line only. This is how a step index, single mode step index fiber propagates. What are the uses of this light? So it is used for long haul communications. I would say example is a telecommunication system which is around kilometers of distances it travels. Now let's move on to the second fiber configuration, that is known as the multi-mode step index fiber. Multi means more than one path. If I am using the word multi-mode means my core diameter will be large. But I have step index profile only. So though the core diameter is large, throughout the core the refractive index would be the same. So multi-mode step index fiber is a fiber having a uniform core material and relatively large core diameter, which results in many paths for light to propagate down the cable. And this is how the fiber looks like. You can see in the diagram that you have a core, comparatively more diameter, and then cladding. So again, two layers are only shown. You can see the curve. This curve represents the index profile, and the curve is a perfect step because we are discussing multi-mode step index. And then on the right hand side, you have a core having a large diameter represented by the white colored rectangle, and both the sides you have cladding, and in between them you can see many different many different red paths indicating that because of the space inside the fiber, because the core diameter is more, light splits up into different paths, and this is how it travels throughout the output. Now let's see some properties of this cable. So we have large diameter core and it has a high numerical aperture also. Because the core is of a higher diameter, it can also accept more light. Because what is numerical aperture? It is known as the light accepting capacity of a fiber. Coming on to the next property, we have light takes many paths to propagate down the cable. Yes, because the core diameter is more. Next property is light entering the cable, it will take variable time to reach at the output end. Why? Because it is taking different paths. So some portion of the data will be received first, some portion will be received later on. This actually leads to dispersion. What do you mean by the word dispersion? It is pulse broadening. This is the pulse, suppose you have sent, but the output will be a broadened pulse or a widened pulse. Why? Because the entire data travels along different path and does not come at the same time. So this gives us pulse broadening or high dispersion. So these were some properties of a multi-mode step index fiber. Now let us have a look at how propagation takes place. So this is how propagation takes place. You can see different one patch comes out, then you have second, then you have third. So this is how your signal is coming in the form of pieces of signal, not a continuous information. This is the reason the uses of this fiber are limited. It is used for medium distance communications only. That is within a building, you can say the LAN communication through the local area network. So these are, this was about the multi-mode step index. That was our second configuration. Now let us discuss the third one, which is known as multi-mode graded index. Now multi-mode means core diameter is more. Graded index means you have a core such that refractive index of the core is maximum at the center and it gradually decreases. So this is maximum and it decreases when it moves towards the cladding. So multi-mode graded index fiber is a fiber having a non-uniform core, maximum refractive index at the center, gradually decreasing towards the edges, and it has a relatively large core diameter resulting in lower modes of propagation to propagate down the cable. Because it is multi-mode, comparatively less, when you are comparing with step index, single mode, it would be less number of modes. And this is how the fiber looks like. So on a leftmost portion, we have the cross section of the fiber shown, and then secondly, you can see the graph There's a clear difference that the graph is not a step, it is like a graded index profile, because this represents the variation of refractive index of core. And the rightmost portion, you can see that instead of different triangular paths, your wave is actually moving like a sinusoidal wave. I'll be explaining you shortly how it propagates. Now let's see some properties of this type of a fiber. So it has a refractive index which is of a non-uniform core, but the cladding is having uniform refractive index. The number of modes is almost half as compared to multi-mode step index fiber. This is because the core is having non-uniform refractive index. Next is pulse dispersion is also comparatively less. What is dispersion? I explained you a few minutes back. Dispersion means broadening of signal. So this type of a fiber, due to the non-uniform core, actually gives us less pulse dispersion. Then we have light takes many paths, but all the content travels through the fiber and reaches at the output end at the same time due to the variation of refractive indices. Refractive index. Why? Because your ray won't travel straight. It will bend, and then it will come out at the other end. And lastly, we have light accepting capacity is also high because it is multimode. Now let's have a look at the propagation of such type of a cable. You can see the path of light. It's a curve, like a curvature. See in the animation. And now you can have a look. This is how the light or the signal propagates through the cable. So it's like sinusoidal motion. It is used for short haul communications, local area networks, having less bandwidth. So these are some of the applications of using such a type of cable. So these were the 3 fiber configurations. Now let us move on to fiber optic communication link. So it's a small topic which will explain you how fiber is used in communication systems. So let's start with what is a fiber optic communication link. So it's transmission, it is transmission of information by propagation of optical signal through optical fibers over required distances. This is the meaning of fiber optic communication link. This is how fiber optic communication takes place. You can see a transmitter. So your electrical signal is given to the transmitter, which converts it into light. This light propagates down the cable. Outside the cable, at the output end, you have a receiver. And from the receiver, we get back the electrical signal, the signal which we were supposed to send. So this is a broad idea. Now let's see what are the important components required for a fiber optic communication link. So the first component is known as a transmitter. What all parts are there in a transmitter? So it is an analog or a digital interface. It can be analog, it can be digital. And if it is digital, it will be in the form of binary signal, 10, 10, 10. So that requires a voltage to current converter. It also requires a light source, and it requires a source to fiber connector, because there would be a specific connector which will connect or which will be connected to the cable so that light is sent through it. Then secondly, we need a fiber optic cable, and the third important component is known as receiver. Receiver requires fiber to detector coupler. As in we had source to fiber, now we would require fiber to detector coupler. We require current to voltage converter, then we require an amplifier, and then we require an analog or a digital interface to convert the signal back into analog or digital form. If the signal was in analog form, at the output end also we would require analog. If the signal was in digital form, at the output end also we would require a digital signal. So these are the basic components which are mandatory for fiber optic communication system. Now let's have a look at the proper detailed diagram. So this diagram here, there are 2 options shown at the input. It can be analog signal like your telephone, the landline signals, or it could be a digital information. So a computer is shown which represents the binary data to be transferred. Now this signal, suppose it is an analog information, it needs to be sent to a coder or a converter. And if it is a digital information, it will give you digital pulses in the form of 1 means on, 0 means off, on, off is the digital signal. So these coder or converter or digital pulses, they are actually converted into light source. So this entire forms the transmitter circuit. From the transmitter circuit, output is light. So this light is coupled to the fiber optic cable. So there we need a coupler, source to cable coupler. So this light travels through the cable in the form of total internal reflection. At the output side, the light is detected. So we would require a detector and we would require a cable to detector coupler. This needs to be amplified because we cannot say there is zero attenuation or zero dispersion. There is some amount of attenuation. So there is a signal loss if the signal is traveling through kilometers of distances. So this needs to be amplified. Then it is given to a wave shaper circuit, and then it is converted to digital pulses and it is decoded either to analog output or it is given directly as a digital output. So this forms our receiver block. So you can see clearly that transmitter needs conversion into light and receiver receives in the form of light, and that needs the conversion back into analog or digital signal. So this is the diagram which represents the fiber optic communication link. So in today's video, we have seen 3 different fiber configurations which are very commonly used. You might be wondering that I did not discuss single mode graded index. First reason is single mode itself is a single path of communication. Secondly, single mode has a very, very small diameter. So varying the refractive index is not possible, and rather it is not needed. We require variation of core refractive index when we are getting multi-mode, or when the core diameter is more, when there are multiple paths of light. Only in that case, due to high dispersion, graded index profile is used. So these were the fiber configurations we discussed, and then we also discussed about fiber optic communication link. The basic 3 components: transmitter, cable and the receiver. Hope you have understood all the topics I discussed very well today. Thank you.